Okay, so my name is Petros Zouzoulas. I was played right up here. I'm with Parsons Corporation. I've been in the Middle East for 18 years now. I'm very excited to be here and have your attendance with me. Before we get started, I just want to stop and reflect on a minute. We are perhaps in one of the most extraordinary times of history, and we are at the cusp of an explosion of capabilities and technologies that are going to reimagine our built environment. I think it goes without saying that most of you know that, but I just want to take a minute to reflect on that. And I think it's a very exciting moment. So before we get started with a use case, I'd like to talk about Peter Diamandis, who's kind of a personal hero of mine. He's a futurist, and he talks about AI and technology in a very optimistic way. I think in these times it's very easy to be pessimistic about the way technology is going and the disparities it's creating, but he's an optimist, and I like to think that we all are optimists here in the built environment. We're going to bring greater value, and it's going to happen through technology and our adoption through technology. It's a bit of a pessimistic quote, I know, but it underscores the point. Either you're a company using AI or you're a company that's going out of business, and I think all of us in this room recognize that, and that's why we're here today. In his book, The Future is Faster Than You Think, he talks about there's 5 major points. Technological convergence, which is the convergence of technologies in new and novel ways. I have a section in the presentation today that talks about that. So it's AI and the convergence with robotics, digital twinning, and of course there's exponential growth. Once we can realize all of these integrations, we have the ability to scale very quickly. The ability of AI for us to converge large data sets means that we can bring together disparate data sets in a way that is usable and understandable, in a way that can benefit the built environment. I'm thinking specifically when we talk about customization, personalization, not specific interests and personalizations related to space. I'm thinking more about customization as related to environment, to changing weather patterns, to specifics of the built environment, and that of course will bring us more sustainable and efficiency in design through the more meticulous use of resources and the better place use. So I'm very optimistic about that. This slide actually kind of recaptures much of what was said earlier today. We see that there's a rapid growth in technology, especially in this space. Venture capital has exploded 15 times since 2019. This is a great indicator that there's a strong trend towards tech integration. It is a Cambrian explosion of artificial intelligence technologies and capabilities, which it's hard to keep up with. And for those of us tracking it, week to week, it keeps changing. I think what the industry is after, what we're all after, of course, is the integration of ideas, information, and platforms in a way that's easy to use. And I pick a very simple model, like you can have a vehicle, a car. You don't really need to know how the engine works, but you can get from point A to point B. And I think that's what we talk about when we talk about integrated. You just have to be the user and understand where you're starting and where your destination is. And the vehicle will be AI that helps bring all this information together to make it accessible. Now, there is a reluctance, as we're finding, to adopt many tools. And the reluctance is as a result of this fast pace. It's as a result of the decision makers not being clear on what's important, what they should be focusing on, since the landscape is changing so quickly. The business case is oftentimes not clear, and there isn't a strategy to develop a business case to understand why should I invest in something. So this is a critical barrier to technology adoption. Of course, we have we talked about the skill gap dilemma. Most of the people in this room, I suspect, are digital gurus, and it goes without saying that these technologies hold a lot of promise for everybody. But we have to recognize that the construction industry is filled with a very broad range of people and skill sets. We have digital gurus and digital Luddites, people who are at the tail end of their career, and young people coming in. So there's a huge gap between those that we have to move through. And of course, that can only happen through education and training, not simply in the form of attending an online course, but through a collaboration And we in Parsons have assigned teams. We have built a team to actually train individuals, and you'll see the result of that shortly. And of course, we have to think about the next generation coming in. Most of us with a bit of gray in our hair often fail to realize that our time is approaching the end, and we have to make this an exciting industry to bring new people into it. And it's not going to happen if we remain backwards. So adopting these tools is going to lead the way for tech-savvy millennials and Gen Z to draw them in and bring in fresh ideas in a way that is going to really transform what we do. So I'm going to give this particular section about reality capture. We touched on this earlier. This comes from a personal pain point of mine. I was trained as an architect, but in the Middle East, I've been on the delivery side. The thing I learned in architecture is that the site prevails above everything else. You must understand the site. And it was really difficult for me to understand how business and architecture and design occurs here in the Middle East when people were so remote to the sites. They never really had a familiarity with the site, and that's the starting point. So my frustration now breached with technology allows people to bring the site to remote locations, and I'll show you that shortly. But whenever we look at technologies, or whenever I look at it, I think about the broad range of people using it. And it has to fit these three criteria. The technology has to be simple, right? We know that there's infinite complexity, and the complexity is compounding, and that becomes a barrier for adoption and of use. So we have to have a technology that provides this simple access, and then it needs to be accessible across all the platforms. And it must create an efficiency. These are the basic criteria. So this is one of the technologies that we've been using. It's a reality capture technology. I had a friend of mine who's an English questioned me on this word I use, complexity. But the truth of the matter, it is a word, and it means the appearance that complex things, simple appearance, but contains complex details beneath the surface. And again, back to the car analogy. A car can look very sleek, very beautiful, but holds quite a bit of complexity below that. So this was my childhood dream. I think we all wanted to have a time machine and a way to teleport yourself, and this technology helps to do that for us. It helps to do that for our customers. They're able to go to the site digitally, and it's not just about eyes on the site, but it's about being connected to the site and being able to bridge that gap between what's occurring and is it happening according to the plan, but also to be able to leverage remote experts. So we had a project in Saudi Arabia where there was a culvert, and I was showing one of our geotechnical experts. I said, "Isn't this a really interesting point? Look at this excavation." And he said, "There is a fissure in the ground," which, because I'm a trained architect, it didn't mean much to me. But he said, "This is a pathway for water. Do the designers know that this should be taken into consideration?" And of course they hadn't, and we were able to connect the designers with that particular point. And that conversation would have never have happened had the site not been available to us remotely. So we saved an incredible amount of time and energy, and ultimately provided a better design. And here's an example of a before and after. It's a simple thing on the surface, but the AI that allows this to occur is quite complex. One of the reasons we prefer this platform, I mean, there are many others, is a very simple interface. There's not much there. My criteria is if I can give it to my kids and they know how to use it, that means everybody can use it. From a site inspector to my commercial manager who can be quite old and not really tech savvy. And this is very useful for a lot of reasons, tracking progress. And of course, as the project progresses, projects become infinitely complex over time. So how do we as consultants truly provide a long-term value to the customer, right? So if we look at a project like this, it was a 70-story tower in Saudi. How do we create a golden thread from the very beginning of the project, the digital information of reality, all the way through the project, and then connected to handover, leasing, and then, of course, onto the asset owners and the final owners. And you can see, obviously, here, again, complexity over time. That activity a few years ago would have taken us hours to do a matching of imagery, and it's a matter of seconds. Of course, we have our BIM models when they're available. Sometimes they're not available. And the nice thing about capturing data in a comprehensive manner, irrespective of where you are in the BIM process, this allows you to go back in time. You can look forward at what's meant to be there in terms of the BIM model. Or in fact, when you're if you've completed the project, you can scroll back in time and actually see and do as-built verification, which is critically important when handing over a project. So in this example, and I won't go through it, we're running short on time, but as an example, we tracked, we surveyed 15 kilometers of cycle track here in Dubai. It was part of a much larger activity. And normally, just to give you a sense of scale, an activity like this for 15 kilometers would have taken traditionally 6 to 8 days, and this activity was done in 1 day. 15 kilometers, 3 hours. We had somebody capture the site within a 3-hour period. The snagging occurred, and there was a 250-page report produced in the same day. So these are real efficiencies that come through the use of the tools. Ultimately, what these tools provide us in terms of value, it's not just for the supervision team, it's for all parties involved. Enhanced visibility throughout the entire process. The accelerated reporting, that's really important. People are not focusing on the production of work, they're focusing on the work. Too much of our time in the past has been focused on the assemblage of work rather than the work itself. Of course, being able to coordinate externally with either the municipalities, with the customers, with other third parties, the designers, this proves invaluable and is a great time saver. And of course, more eyes on the site, the safer the site is. So the last example I'm going to show you is slightly different. It's this convergence of technologies, which I mentioned. We're currently working with a group out of the UK. It's a high TRL, technology readiness level, a high startup. They are working on disrupting tunneling. So we know that tunneling first began in the modern method, began in the 19th century. The observation, of course, was a grub was chewing its way through a ship, and it was secreting an enzyme that was creating a hard shell. So this early form of biomimicry has evolved into what you see here, which is a tunnel boring machine. And it's created, it was transformative at the time, but fundamentally we've been doing the same iteration for 180 years. So this new approach does away with a tunneling boring machine, and it synthesizes all of these technologies by allowing horizontal directional drilling to occur, creating a digital twin of the subterranean environment, using artificial intelligence to bring all that data set, to fuse all that information together, and then being able to use swarm robotics to three-dimensionally print a tunnel in the earth without any people being underground. So there's an image of this. It's a short video I'll show you. So here what you see is a representation. This and you can imagine for us old enough to remember what a dot matrix printer is. These swarm robots move back and forward. The first robots map the earth, create the digital twin. The second robots come in and then inject grout into these what they call hyperbits. And then once these hyperbits have ejected enough grout, it creates a hard shell, which then the swarm robots who are mapping can go back in, remap it to ensure that it's all the ground has been consolidated. And once that occurs, the spoil can be excavated without the intervention of humans. Eventually, this is intended to be a completely autonomous process. So you can imagine how disruptive this is. Well, one of the most challenging parts of construction is having people underground, and this could fundamentally disrupt how we do everything. So we're currently looking to pilot this in the region, and we're working very closely with this team. So this would occur, and then what I'm showing you in a 360 view there is what these plumes would look like. This process would occur in 4 phases. It would be preparation of the ground and the physical surveying, the 3D printing, the excavation by autonomous vehicles, and of course the completion of it. You can see there's no lining here. The customized lining. So this highly customized kind of use case, and the scale could fluctuate from simple underpasses, sewage tunnels, much larger tunnels. So this to me, I wanted to present this, even though it's not something that's active here in Dubai or in the Middle East at this time. This is a real convergence of all the different kinds of technology that we've been talking about today.